Good evening, ladies and gentlemen. My name is Eric Paxton. Today is October 5th, 2025. We are going over FTH 223 Module 3, Week 3 assignment. And that is going to be with this firearm here, the SAR B6 9mm. We'll go ahead and show clear right there. Nothing in it. Nothing in the chamber. There is no ammunition present. For part 1, we are going to do a reverse engineering, basically, of the recoil spring guide, or the rod, the ejector, and the firing pin. For each of those, we will give a dimensional hand-drawn drawing that includes all of the applicable measurements, and it should be done with precision using calipers or other precision measuring tools, which we do have present here. And for the disassembly, we will be using this hammer. We'll have our safety glasses for the spring removals, and we will have a assortment of punches. The one you use the most is the 3/32. Sometimes you use the smaller one to kind of get into a tighter hole. But that's kind of a, an as expected kind of thing. We will do our disassembly. We will take those 3 parts, do our drawings, make our measurements, and then for part 2, we will come back and do articulate why the skills developed and demonstrated in part 1 are important to a gunsmith and understand, or for them to understand, and also we'll explain and describe when these skills might be needed. Then we will continue on to part 3, which is, in the guidance we received from the lecture, demonstrate how to properly check headspace in your provided firearm and articulate why understanding this measurement is so important. So right now what I'm going to do is I'm going to pause the video. I'm going to do the detailed strip of the firearm. I will do my drawings and come back to show you what the drawings look like and the given measurements of each one of those pieces after we're done. So you guys just hold on, and it'll be just a few seconds for you. We're almost instantaneous, but it'll be a few minutes for me, so hold on. Okay, ladies and gentlemen, we are back. We've done our measurements, we've recorded our findings, and now we get to show you those. And I'll go ahead and pick the camera up, flip it around, and point. See it. We have our firing pin, which looks just like this. You can see we've got our drawing of it there. We have our ejector right here, which looks like this, roughly. And then we have our recoil spring guide, which looks pretty much like this right here. This is our recoil spring guide, or your guide rod, as people would call it. For our firing pin, our overall length was 2.9 inches in length. The nub on the end was 0.15 inches tall. From the end of this little gap here to this gap was 0.3. The thickness of this portion where that flat space is was 0.199. The overall length of the skinny portion of the firing pin, that long part you see protruding there, was 1.6 inches. For the ejector, the little ejector portion right here that protrudes out was 0.5. The gap between that and the little rise on the back was 0.6. The overall height was 0.49. The height from the gap to the top of that was 0.15. And from the back to the bottom curvature edge here was 0.93. For the recoil spring guide, the overall length was 5 inches. The thickness of the rod was 0.26 inches. The length without the cap on the end was 3.6. The thickness of the cap was 0.09. And then the height of the cap from top to bottom was 0.39. And we'll place it back in the holder. Okay, so for part 2, to articulate why the skills developed and demonstrated in part 1 are important for a gunsmith to understand, and describe when these skills might be needed. That's kind of a twofold deal that's going to get rolled into one piece, and I would say that, those are important to understand because you need to know that the parts that are in the firearm are still within the specified limits of what their acceptable allowance is. So you should know that the guide rod is this long, it should be this long. This one we have in here either does or does not match that. That goes with pretty much all the parts, because if they're too big, it's not going to work. If they're too small, once again, not going to work. If they are worn beyond the limits of what is the allowable acceptance, then we have a problem. Those skills also might be needed in the offhand chance that you have to manufacture one of your own because the company that made the firearm no longer makes the firearms, the parts are no longer available, and if the customer wants that firearm to function, and if it's at all possible, you may have to make your own part. And that's kind of how that one goes. Let's see. We're going to go ahead and pause this video right here and set up for our headspace measurements, and we'll do that part next. Okay, ladies and gentlemen, as you can see now, we have our 9mm go, no-go gauge set. We're going to go ahead and pop that open. Sometimes these get a little sticky because they have those nubs on the inside. And usually inside that set you'll have a go and no-go gauge that are shaped like the cartridge themselves with a rubber ball spacer between to keep them from being damaged. To do this test, you take your go gauge, place it inside of your barrel, which you can see is in fact empty. Place it inside your barrel, you place that inside of the firearm, slide, and you pull it closed. You can see there's no gap inside of that, meaning that it meets the acceptable tolerance for the go gauge. You then place the no-go gauge into the firearm, slip it down inside, and you can see that there is a slight gap protruding, that it does not close all the way, meaning that this firearm does in fact meet the acceptable limits of what is to pass the go, no-go test. The no-go gauge should not fit, and the go gauge should fit perfectly. Understanding why this measurement is important is quite simple. It just boils down to the fact that if the go gauge allows it to close, then it goes completely into battery, meaning the firearm, the casing is up against the breech face, the slide is completely closed, no gaps, no openings. If the no-go gauge does what it's supposed to do and it does not close up all the way, it leaves a gap, which leaves the firearm out of battery, and if that were to go inside, then it means the firearm has worn beyond its acceptable limits and is probably not safe. And if it does not close all the way on the go gauge, that also means that the firearm, because it does not close, does not meet the acceptable standards and could become dangerous with an out-of-battery detonation, causing a rupture of the side of the firearm right around the slide and the breech, causing injury to the operator or anyone standing nearby. In the worst case, in the least amount, it could do just damage to the firearm, but either way, not acceptable. So that is why that measurement is extremely important to understand. And for that, we appreciate you guys tuning in. We're glad to see you here, and we will see you in the next video.